very much, Ming. I'm really excited to be chairing the Data Jamboree this year. So last year I was part of the Jamboree. I did the R portion, and this year we have Lucy D'Agostino McGowan doing the R portion. We also have Shannon Tass doing the Python portion and Haiying Wang doing the Julia portion. So the idea here is we're going to see three different presentations from three different languages, and they're all going to be analyzing the same data and thinking about the same exploratory data analysis questions. So it's a really exciting way for everyone to see sort of how these different languages approach data analysis, and I'm really excited for our speakers to be here. So I'll introduce our first speaker, who is Shannon Tass. Shannon is an associate professor in the Department of Statistics at Brigham Young University. She earned her PhD from Rice University and MD Anderson, where she worked with Keith Baggerly on developing methods to analyze protein microarrays. Since joining faculty at BYU, she's also done work in spatial and environmental statistics. Her current research interests include practical applications of machine learning and large language models in public and mental health. She's developed several data science and machine learning courses for the BYU Department of Statistics, and also works to establish and strengthen interdisciplinary data science connections across campus. So Shannon, thank you so much for being here today, and can't wait to see some Python code.
Great, thank you all. Let's see, let me share my screen. All right, so just to do the confirmation, can everyone see that and hear me? Okay, so thank you again for having me. You can find this code on my GitHub. It is, my GitHub username is just ESNT, my initials, and then there's a repository called Jamboree, so you can find this there. And I just wanted to thank my student, Sam Spackman. I might have to leave before the end of the session. And so if there's questions at the very end, my student, Sam, said he'd handle them for me. So just to briefly explain the data, we are working with 311 service request data. This is data available through NYC's Open Data Network, and 311 service requests are sort of a place where I guess citizens can report non-emergency issues to the city. This particular data set, I think, was used for a class at UConn, and it's just service requests for a week in January. And just to give you an idea of what people might call in about, here is a graph of the top 10 complaints that people make. And so we have illegal parking is the top one. There's also lots of noise issues. Okay, so that's just a brief overview of the data. I just wanted to tell you a little bit. There's lots of ways to use Python and lots of IDEs. What I use for my classes and for me, I like to use Anaconda. So this is all in an Anaconda, and then I use Visual Studio Code. I've been using that for about a year now, and I'm really loving it. And I know there's new extensions for R and Posit and Quarto, so it's you can use Visual Studio Code for almost anything these days. So I set up an environment, and just if you wanted to replicate exactly what I do, this is how I set up my virtual environment in Anaconda. Okay, so that's kind of just the preliminary of how I set up my Python. So before we start, usually at the beginning of my Python code, I'll just install all the packages or import all the packages that I'm going to be using. So some of the ones that I'll use are Pandas and NumPy for handling data frames. My plotting libraries will be Matplotlib, Seaborn, and Plotly. Plotly uses interactive plotting. Then I'll use some packages for doing statistical tests, stats models, and SciPy. And then scikit-learn is one of the main machine learning packages in Python. Excuse me. And then I have just some other packages for zip codes, for geocoding, and for explaining machine learning models. And again, this is just so you can, for reference, I'm using version 3.10.13, and these are the versions of the packages that I'm using. Okay, so the first thing to do obviously is to load in the data, and I just use the simple pandas read_CSV function. And then a few things that I like to do when I first read in a data set is to just examine it, look at the head and the tail, look at the info. Here I'm just making a copy of the data set, so I have an original copy as I do some data manipulations, but you can see that there's 54,469 rows and 41 columns. These are the last 2 rows of the data set, and so we can kind of see what it looks like. Info is a really helpful function that will just give me the range of my kind of the index, then also the variables and what type they are. It also tells me how many missings there are, or rather it tells me how many non-missing values there are. So since a lot of times I don't like to do math in my head, I will just do this function is NA to count the number of missings, or here I've done it in kind of this fancy way where you can see the number of missings and the percent of missing values. I'm just showing the first 10 rows, but you would just take off that head right there to show the whole, all of the variables. So usually as I approach a problem, I just examine the data set, make sure it read in the way I wanted, and kind of get some facts about it. So now I'll talk about, and I probably won't, 15 minutes is not a ton of time to go through all the questions that they asked us to go through. So I'll try to highlight some of the things that I thought were interesting, and maybe the other speakers will highlight different things. So the first thing was just to fix the column names. Here, there's lots of ways to do this, but here I'm using one of my favorite, I guess, I don't know, things about Python, which is the list comprehension. It's kind of a way to write a loop in one line. And so this is just saying for each column in my columns, I'm going to make it lowercase and replace the spaces with an underscore. So we can see that that then fixes the column names so that they are all going to be the same across the languages. We were asked to check for inefficiencies or errors. So I'm checking a couple things here. I'm converting it to date time, and by default, if I don't do anything, it will throw an error if I have invalid dates. And since I ran it and I didn't get an error, I don't think I have any invalid dates, but we can see that there are at least 1893 values that have the same exact close date as created date. Or that it's the close date is before. So those, obviously there's something going on with those close dates, because there should be some time between when the issue was created and when it was closed. So we could decide what we wanted to do with those. Here, what I decided to do is just create an indicator so I could drop that later. So here I've just created this variable. It's a 1 if there seems to be a valid close date, a 0 if the close date is missing, which would imply that the ticket or the issue is still open at the time the data was collected, and then -1 if it's one of these weird close dates. Then there's a lot, the next question was, are there any invalid values for any columns? And as we saw, there's 41 columns. There's a lot of things to consider. So I just sort of looked at zip code, latitude and longitude, and borough. I looked at whether all the zip codes seem to have 5 characters, which would be the right character. Some of them have 4 characters, but those are just the NAs. So it seems like all of my zip codes are either NA or valid zip codes. Here, I also just found a data set with all of the valid zip codes in the state of New York. And so I'm merging it and just kind of seeing if there are any data, any zip codes in my data set that are not inside the New York City zip codes. And it looks like we had 3. There's a couple of these 10,000 zip codes. There's this 1, 2, 3, 4, 5 zip code, which apparently is a valid zip code, but it was more likely used as a placeholder in this context. And 1097 or 10977 is also a valid zip code, pretty close to New York, so maybe that was valid. Here I just thought it would be fun to make a graph of where those bad zip codes are. And here I am using Plotly, and I actually find it a little bit difficult to plot maps in Python. I feel like R handles that a lot better. So whenever I have to do geographical plotting, I always use Plotly, which I think handles it much better and also allows, for interactive. So we could zoom in here and see, oh, a lot of those weird zip codes happen to be in Central Park. And I don't know why they coded them with the 10000 zip code, but that's where they are. So, and then this one was that, oh no, that's another 1000. Anyway, okay. You do, in order to kind of put the map behind it, I wanted to just mention this. You have to sign up for a Mapbox token, and you can do that for free. I have the link here where you would sign up for Mapbox. And then this is, again, just kind of a shout out to students, or just what I always do whenever I am going to publish code on GitHub, but I need to use an API token. I always save that token in a text file, and then I can open it. Like here, I'm just using the open to read that text file, and I add my API file, the file with my API token, to my git ignore, and then I can access the token when I'm using it in my code, but it won't get pushed up to GitHub. So that's good practice for accessing API keys inside something you're going to publish to GitHub. I didn't see, how much time do I have left? Does anyone know?
You've got about 5 minutes.
5 minutes. Okay. So I'll just maybe just skip down a little bit. You can see there, I hopefully made this really well commented, so you can read through this notebook and see everything that I did to kind of answer the questions that are posted on the Data Jamboree website, and kind of see some of the things that I did. I actually think I might have to run it though, so I'll just run it really quick, but I probably won't talk about it. Okay, so I'm gonna skip the filling and we'll go down to the data manipulation portion. So here they've asked us to focus on only requests made to the NYPD. So I'm dropping anything that's not in the NYPD. I've also dropped a couple of other things, like here is how I would drop all of the rows that have a missing incident zip. So we filled a lot of those in the previous steps, but if they're still missing, I think there's only like 400 that might still be missing, then I drop those. I'm also dropping, oh, here I'm not dropping anything. I'm just counting. I'm just showing you that close date indicator that we made. So none of the GitHub, sorry, none of the close dates are invalid the way we said. There were no negative ones here, and then there's only one case that still seems to be the issue. So then the main kind of question is going to focus on the duration variable. So this variable that just is the time from creation to when the date was closed. So since I've already converted these into date time objects, I can just take the difference. in order to get the duration in hours. So first I get it in total seconds and then convert it to hours. And then I'm going to create a variable here that just tells me whether or not it was a weekend or a weekday. So as a date time object, I can pull out the date of the day of the week. And then anything that's 1, 2, 3, 4, 5 is a weekday, and everything else is a weekend. And we can visualize that. So here I'm just using Seaborn for my visualization. I can see that this graph on the right is the exact same as the graph on the left, just without the outliers, so we can see a little bit easier that there's doesn't seem to be a huge difference between the duration between weekend and weekday. And I run a t-test actually and find that the t-test is not significant. I think if you did a non-parametric test, like a Kruskal-Wallis or a Mann-Whitney test, it does turn out to be significant. But just for fun here, I made bootstrap confidence intervals, and it also shows that there's not really a significant difference between weekday and weekend. We do the same thing for borough, and it does look like there's a little bit of a difference for boroughs. The ANOVA test is significant, and then I do some multiple comparisons and see that most boroughs do have significant differences with each other. Sorry, I feel like I'm going kind of fast, but I know that there's a lot to do. And then the question, it asks us to merge it with zip code data. So there's a package that has some zip code data, sorry, not zip code data, census data. And so some of the census variables you can see here are median household income, home values, housing units occupied. So then finally, at the end, what we're going to do is just do a binary classification where we create a variable that is a 1 if the duration is over 1 hour, and a 0 if it's under, 3 hours, not 1 hour. And one thing to notice is that there is a lot of imbalance here. About 83% of the values were less than 3 hours, and only 16% were more than 3 hours. I do a little bit of processing, and then I just wanted to show you two things about running a logistic regression. So there's really two ways you can run a logistic regression. You can use the package stats models, which would give us more of an output that we're expecting from R. So that will give us kind of the information about the model, and then the coefficients and whether each of those coefficients are significant or not. And we can see that we can look at the accuracy. The accuracy is 83%, which we might think is good, but if we remember that there was a lot of class imbalance, we see that actually accuracy is not a very good metric in this case, because we're classifying almost everything to be the negative class here. And so another metric such as F1 or recall might be better. I also show you how to do it in scikit-learn. Scikit-learn is the machine learning package. And one thing that's just really important when you're doing a logistic regression in Python is that the logistic regression function in scikit-learn does use regularization by default. Stats models does not, but scikit-learn does. And so again, this is always like what I tell my students is to, read the documentation and look at what each of the arguments are telling us. But it doesn't do any better even with the regularization. That's my ROC curve there. And then I run a random forest model. I forgot that this takes a second to run, but I'll just show you. I think I have a run version of the code that the ROC curve for the random forest is a lot better. So the random forest is able to do a lot better. And then I have some information about looking at the important variables, but I'm probably out of time. So that is all I'm going to talk about today. And I know there were questions that came in, but I didn't see them. So if there's questions, let me know.
No worries, Shannon. Thank you so much. We are going to be doing questions at the end. But yes, thank you for the virtual claps for Shannon. Thank you so much. And there was a shout out to your beautiful notebook, which I have to second. I agree. It's very well organized and lovely. But thank you so much, Shannon.